Solid, liquid, and gas, oh my! Sorry, I just finished watching The Wizard of Oz. It doesn't matter, but it does. Because today, we're going to talk about matter, specifically, particle theory and the states of matter. Particle theory. All matter is made up of particles. All particles of one substance are identical. Particles are always in motion. Temperature affects the speed at which particles move. There are attractive forces between the particles. Closer the particles, the stronger the forces of attraction. Now, you know the basic states of matter, right? Solids, liquids, and gases? You might also have heard of plasma. Plasma is ionized gas where enough energy has been provided to cause electrons to free themselves from atoms or molecules. Plasma is actually the most common state of observable matter in the universe. Even though over 80% of the mass of matter in the universe is made of dark matter. Plasma occurs naturally on Earth, and we see plasma almost daily because the sun is a giant ball of plasma. We have even harnessed this state of matter in some of our technology. But for the purposes of this video, we're going to focus on the 3 celebrities of matter, those states that you know well. From an early age, we all have a basic understanding of what is a solid, what is a liquid, and what is a gas. Solids hold their shape. The molecules or atoms in a solid are stuck in a specific structure or arrangement. The atoms still vibrate and the electrons fly around in their orbitals, but the atom will not change its position. You are solid, for the most part. Your hand will not willingly go through something solid. Liquids flow and take the shape of their container. They are virtually impossible to compress. The particles in liquids are still touching, but able to move around each other. You can swirl your hand through water with some resistance, but your hand still moves about. Gases have molecules and atoms full of energy. They're constantly moving around. Gases will fill the container they're in. For the most part, you can wave your hand around the air without much difficulty. The molecules are far enough apart that there's lots of space for solids, liquids, and other gases to move about. Because of the space between the particles, gases can be compressed fairly easily. And gas molecules will move from an area of high pressure to an area of low pressure. Now, let's take a step back for a bit and talk about atoms and molecules. Atoms and molecules are very small. You know how all living things are made of cells? Cells are small too. Your cells are made of atoms and molecules. You need about 400 times magnification to see cells. Cells are small, microscopic, but atoms and molecules are even smaller. We will not see individual water molecules with a light microscope. You need very powerful instruments, like an electron microscope, to see water molecules. These types of microscopes will magnify things 500,000 times. The basic components of matter are very small. Now, back to the matter at hand, pun intended. The substances change from one state of matter to another, depending on how much energy we add to or remove from the atoms or molecules. Heat up a solid, and the particles will move faster until they reach a liquid state of matter. Cool down liquid sufficiently, and the particles slow down until they become rigid and locked in place. You can cool down a gas so much that it becomes a solid. Dry ice is solid carbon dioxide. When you have it at a normal air pressure, it will change to a gas directly. Because it skips the liquid state, we call it dry ice. No melting. Changing from a liquid to a gas also involves the addition of heat. Water boils at 100 degrees Celsius. Liquid nitrogen will boil at room temperature because we have to cool it to minus 196 degrees Celsius for it to be liquid. Expose it to normal air pressure, and it will turn back to a gas. Gases cooling and turning to a liquid is called condensation. We see this in the form of precipitation all the time. Gaseous water cools and condenses into liquid rain. We see physical changes of matter around us all the time that we take for granted. It's amazing to realize that the addition or subtraction of energy can change the behavior of this matter by changing its form. Those tiny particles dancing around control so much of our lives and how we interact with other matter.